Measuring initial reaction rate. For reactions when a sudden color change when a product reaches a certain concentration. This case iodine clock solution reaction that we're monitoring, H2O 2 aqueous plus 2I minus aqueous plus 2H plus aqueous to form 2H2O liquid plus I2 aqueous. What happens in this reaction iodine clock solution? A small amount of sodium thiosulfate solution and starch added to the reaction mixture. Sodium thiosulfate reacts instantly with iodine being formed. Once all the sodium thiosulfate has been used up, any more iodine formed stays in the solution, turning the starch indicator blue-black. Varying the concentration of iodide or hydrogen peroxide H2O2 while keeping everything else a constant will give us different times for the color change. Makes sense, and therefore we can work out the reaction order. For reactions that produce a precipitate which clouds a solution, we want to measure the time taken for mark underneath the reaction vessel to disappear from view. And for other reactions, we need to work out the initial reaction rate by measuring the time taken for a small amount of product to be formed. Definition of continuous monitoring. We can follow a reaction from the beginning to the end by recording the amount of product/reaction you have at regular time intervals. Gas volume. If a gas is given off, we can collect in a gas syringe and record how much you have at regular time intervals. And then we can find out the concentration of the reactant at each time point by using the ideal gas equation to work out the moles of gas, and then use the molar ratio to work out the concentration of each reactant. If a loss of mass happens, if the gas given off the system loses mass, we can measure at regular intervals with the balance, and then use the mole calculations to work out the gas loss and therefore work out the mole concentration reaction left. Color change. We use a special gadget called a colorimeter, and what it does is it measures the absorbance, and which is the amount of light absorbed by the solution, and if it's a more concentrated color of solution, higher the absorbance. Higher the absorbance, more concentrated the color of solution. More concentrated color of solution, higher the absorbance. So what we do, measure the change in absorbance. We plot a calibration curve, a graph of known concentrations of colored solution plotted against abundance. During the experiment, we take small sample from reaction solution at regular intervals and read the absorbance. And then we use a calibration curve to convert absorbance at each time point into concentration. Change in pH. If a reaction produces/uses H plus ions, the pH of the solution will changes. Therefore, we can work out the measure of the pH solution at regular time intervals and calculate the concentration of H plus ions.